Operations on integer types. Bitwise operations only make sense for integers. The result of bitwise operations is calculated as though carried out in 2's complement with an infinite number of sign bits. The priorities of binary bitwise operations are all lower than the numeric operations and higher than the comparisons. The unary operation tilde has the same priority as the other unary numeric operations plus and minus. This table lists the bitwise operations sorted in ascending priority. X or Y, bitwise OR of X and Y. X exclusive or Y, bitwise exclusive OR of X and Y. X and Y, bitwise AND of X and Y. X less than n, X shifted left by n bits. X greater than n, X shifted right by n bits. Tilde X, the bits of X inverted. Notes: negative shift counts are illegal and causes a value error to be raised. A left shift by n bits is equivalent to multiplication by power 2 n. A right shift by n bits is equivalent to floor division by power 2 n. Performing these calculations with at least one extra sign extension bit in a finite 2's complement representation, a working bit width of 1 plus max x dot bit length, y dot bit length or more is sufficient to get the same result as if there were an infinite number of sign bits. Additional methods on integer types. Let's do it. X or Y. So I have this conversion tables, decimal to binary. 10, this is the binary representation. So let's say a is equal to 10, print bin a. So it should print binary representation. Okay, 1010, that is correct. If I perform a is equal to tilde a and try to print bin a, so it should print 0101. Why 1011? I didn't understand. C is equal to tilde a. Let's print C. Same output. If I say A or Y, okay, B is equal to 10. Same. C is equal to same. If I set this as binary to decimal, so 0101 5. Okay, so let's put it 5. A or B. Okay, and if I say C is equal to A and B. So print B in C. So here it will do the operation following operation 1010 and then 0101. So the result should be 0000. Let's print it 0. Okay, because 100 0 1 0 and 1 0 1 0 0. Okay, let me do E is equal to, let me do 1011, that is 11. So if I do this, C is equal to A and E, so the operations result will be 1010, then 1011, and operation, so 111 000 111 010. So it should be equivalent to A. Let's print it. Print C. It's A, that's correct. And if I print binary representation, so it should be 1011 010. Okay, and here, so we did this exclusive XOR. Okay, so XOR operation, if I go back, delete this, so if I say C is equal to A XOR B, so it should be 1010 A, and then B 0101. B is 0101. Apply XOR operation, so the result will be 100 010 100 0. Okay, 111 1 or 0. Okay, 1 or 0. Yeah, sorry, 1111. So, and this was XOR left shift. If I perform left shift operation, for example this one, left shift by 1, so it means 1010 will become 01 01 01. I'm not sure, but let's see. 1010 1 0 1 0 0. 10100 10100 20. Yeah, 10 multiplied by 220. Correct. This is 10 multiplied by 2. Yes, correct, 20. And if I print its decimal value, so see, it should print. Okay, so and then if I do this, So it should be 5 5, right? 101. Okay, till bits inverted. If I say some sample bits inverted 1011 1 1 0 1. I see. Additional methods on integer types. The integer type implements the numbers.integral abstract base class. In addition, it provides a few more methods. Integer.beatLength. Return the number of bits necessary to represent an integer in binary, excluding the sign and leading 0. So if I say print n dot bits length print minus 37 minus 37, this one is this. Okay, so let's print n dot bit length. Yep, thank you.